We are covering actionable insights using TIBCO Spotfire at Texas Instruments. So Texas Instruments is a semiconductor company, and it has 14 manufacturing sites worldwide, which include 10 wafer fabs, 7 assembly and test factories, and multiple bump and probe facilities. Our two reportable segments are analog and embedded processing, and we report the results of the remaining business activities in other. Last year, we generated $14.46 billion of revenue, and our focus is on products sold into 6 end markets: industrial, automotive, personal electronics, communications equipment, enterprise systems, and other. So our team is the Data Analytics Solutions team, and we collect, enrich, and deliver data insights for functions across Texas Instruments. And the goal is to enable organizations to become more effective and efficient through the use of data. So I'm Tony Ray, and I primarily support the sales organization.
Hi, I'm Jennifer Liu, and I mainly focus on supporting pricing organization with my data analytical and data science experience.
Okay, so at TI for our enterprise TIBCO Spotfire environment, we have approximately 150 scheduled dashboards that are used by an average of 1,500 unique users per day and 4,000 unique users per month. So we will cover 2 case studies in this presentation, and the first is an interactive opportunity tracking tool that our sales team uses. So users of this tool would like to be able to quickly analyze performance of accounts and products and identify gaps and opportunities. In the tool, the users can view several different data sets concurrently, including actual revenue or historical data, forecast data, and expected demand data. The user can identify or tag an account product combination that should be tracked, and the data is saved as a goal using a stored procedure. Going forward, the progress is reported for any saved targets using a snapshot of the data and when the target was created, along with the current status. So summarized data is generated for the dashboard in the data management environment and used along with security tables to load personalized data. Users can select a scorecard or role which has a specific list of associated accounts and products, and data is loaded on demand based on the role selection. The users can then view analytics that compare historical revenue data to forecast data, and several comparison methods are available based on user feedback and specific business cases. The comparisons include the current quarter amount compared to the average of the previous 4 quarters of revenue, or compared to the previous quarter alone, or compared to a linear fit estimation using the last 4 quarters of revenue data. The users also view analytics that compare historical revenue plus forecast data to expected demand, and the same analytics or comparison methods discussed previously are also available in this section. And the final section of analytics compares quantities shipped to target quantities for any pricing agreements that we have in place. And this allows account managers to track price agreement compliance for assigned accounts. So users can mark data in any of the visualizations and add a potential target. An Iron Python script is used to tag all of the data customer product combination that is marked, and then the resulting potential targets are all shown together, and the user can select one of these targets to create a target. A stored procedure is used to write the data to a target table in the database. Some of the data written to the table includes the customer, product, a snapshot of the current conditions, and a user input revenue target. A stored procedure is used to write the data to the target table in the database. Some of the data written to the table includes customer, product, a snapshot of the current conditions, and a user input revenue target. All existing targets are then loaded to the dashboard and displayed to track the status. The target table is refreshed each time a target is created, so the user can see any new targets that have been created during the current session. This tool combines analytics and sales team workflow into a single tool, so they can analyze subsets of data, revenue versus forecast, forecast versus expected demand, or revenue versus pricing agreements. And the tagging functionality in Spotfire is used to mark a superset of the current marking to be considered for the setting the goal. Allowing users to identify opportunities and capture the opportunity parameters to track progress in the same tool has reduced the amount of time and additional work of documenting the goals and manually tracking the progress. Early usage has shown success in the sales team ability to identify targets and track them to closure. Now I will hand it over to Jennifer to discuss the Pick Best Curve tool for optimizing pricing strategies.
So I will be covering the case study talking about the Pick Best Curve tool, which is used by our pricing team to set optimized pricing strategy. TI is a very huge semiconductor manufacturing company. The products in our company, the price ranges from single-digit cent to thousands of dollars. So to setting the product's price at the right market level is very crucial to our company. And then we need to understand what is the current best price in the market and how much the customers are willing to pay with this competitive market. So the business team will need a solution or tool to connect the external customer information as well as our internal product information to have a thorough understanding of the current market change. And then they will be able to take action to quickly adapt the market and to have an optimal strategy. So we created this Pick Best tool in this Spotfire environment to help to solve this problem for pricing team. So the center of the tool was an R script data function written by several basic R packages. And then several data science models were created to help to find the best fitted curve with our loaded pricing data. So the inputs will be data tables already loaded in Spotfire, and some document properties were used to help to configure the model, as well as some filters, expressions, and markings. The model will be activated by Iron Python action control script. So once the model engine was activated, the model will start to run, and the output will be loaded into several other data tables and property values. The output can also be selected to reload it to our internal databases if needed. To give a more direct view on how this model engine works, here are some screenshots to help to show how the model engine will work. So first, the data will be summarized in the database and be loaded into the Spotfire. And then several KPI charts were created based on the data to help the users to identify the products they think they need to adjust the prices. And then they will configure the model to decide what kind of data they want to load into the model as inputs. For example, they can focus on certain type of customers, and they can select what are the invalid data to be excluded as outliers. So once the user has decided the configuration, they can click the price model button to activate the engine. Then the engine will start to run with the written R script, and the R script will read the data, run the models, and write the output into the data tables to be consumed by Spotfire visualization. And users will view multiple model outputs, and the model with the least error will be automatically selected. But if the user need to override the selected model, they still have the option through the drop-down box. Then visualization with data inputs will be generated, and the curve will be the one with arrow, show the selected model, and the users can evaluate the model output and decide whether they want to load it back to our database for further execution. So to summarize, this Pick Best curve model is able to combine data science models and data visualization analysis into a single tool, and provides a user-friendly, flexible, adjustable model configuration with inputs directly from the Spotfire visualization. And it also enables the users to execute further analysis with the model inputs and take actions to load the output back to our database. So far, we have received several positive feedbacks from the users. They think this tool is helpful in terms of setting the winning price, which is quite important in this competitive market. And the company can also get benefit by maximizing the market share and also improving the pricing efficiency. So that's the introduction of this tool. Thank you.
Thanks, Jennifer, for covering the Pick Best Curve tool for optimizing pricing strategy. And just as a summary, TIBCO Spotfire has been used to develop workflow tools that enable our sales and pricing organizations to take targeted actions and solve business challenges. Multiple analytics techniques, data prep, modeling, science are combined with TIBCO Spotfire functionality, scripting procedures, and visualizations, allowing for a single solution to be delivered to the business user. And tools are driving earlier identification of issues, improved efficiency, and successful next steps. Thank you for allowing us the opportunity to review how we've driven actionable insights in using TIBCO Spotfire at Texas Instruments.